All right, we are in Chapter 3, Section 5. This is Arithmetic Sequence as a linear, is it function? Functions, yes. So this is for I-1 or Integrated Math 1. Before we get started here, I'll just go over some of the features. So on your screen, this is the same screen you should see when you go into your student view to do your homework, with the exception of two pieces. You will see a due date on your screen. I do not get one on the teacher preview. Right after that, you will see attempts, and it will say which attempt you're on. Of unlimited attempts, we always have unlimited attempts, meaning I can go in here and complete this assignment as many times as I would like until I'm happy with the grade or I have 100%. That has to do with clicking the submit button, which we will talk about in just a minute. This is the number of questions. So I have 7 questions on this particular assignment. Grading policy is best score, so whichever attempt is the best one is the one you get to keep. And partial credit is enabled, meaning if I do 1 of 7 questions and I get it correct, I get to keep my points for the 1 question. Once you start your homework, you must finish it before you can work on anything else. And what that means is if I click start here, on your screen, this is the second piece you won't see on my screen, but you will see it on your screen, you have down here the submit assignment button. No matter what, when you want to leave this screen, if you've answered 1 question or multiples or all of them, it doesn't necessarily matter what you've answered, to leave this screen, you click submit assignment. And what that does is number 1, it tells the teacher where you are, what you've been doing, what your percentage is, but it also stops the system from locking you out of all of your other assignments. Because if you don't click submit assignment, it assumes this is the one you want to come back to next, and it'll force you to come back to this one. So just remember, always click that submit assignment button. And when you do click that button, if you've answered the first question and you've gotten it right, and when you click that button, when you come back in, you do not have to do number 1 again. It's quick retake, meaning that whatever you've answered correctly is still correct on your next attempt. So that's a very nice feature there. We have these 3 tools on the side. Explanation literally explains this problem you're looking at, so it's going to give you the solution and the answer. So you will lose your attempt on it. You'll get an X on here, but you get to see the solution to this problem, and then you'll have to come back in on another attempt to actually get points for it. Example just opens this pop-up, which shows you how to do this type of problem. So it'll walk you through, and it's nice and color-coded here, so it walks you through pretty nicely on what to do. And you can click on it again for another example if you'd like. And then there's the message center. So when you click on this, it actually attaches a screen of this question to the message so that your teacher knows exactly where to come back and help you. All right, let's go ahead and get started here. So we are going to start working on arithmetic sequences. And if you don't know what that means, arithmetic means addition or subtraction. So we're going to be looking for patterns of addition or subtraction. First, they're just going to give us an equation, and they're going to ask us to plug it in. So if you notice, there's a, n, and then there's also an n in this middle part here. And they want us to find the first 4 terms of the sequence. Remember, a sequence is just a pattern. 1, 2, 3, 4 is a sequence. There's a pattern there. I'm adding 1 each time. So in this case, we're going to be starting somewhere other than 1. But what this means is this is the nth term. So whatever term it is you're looking for. If you're looking for term number 1, the first number in the sequence, then this would be A1, and you'd plug a 1 in here for n. If you're looking for the second term or the second number in the sequence, you'd go with a 2 on these ones. So these are just kind of placeholders for the term number. That's all n means. So if I come over here and I have A equals 36 minus 8 minus 1. All right, so the very first one we're looking for, what am I doing, is term number 1, or the first part of the sequence. We want to know what the sequence starts with. So I'm going to plug a 1 in here. And as we work this out, we would just do it the same way we do any other equation. So a to the 1, or the first term of this sequence, is going to be 36 minus 8 times 1 minus 1. So 1 minus 1 is 0. And 8 times 0 is going to be 0. And 36 minus 0 is just going to be 36. So if you notice, when I put the 1 in there, and this is going to happen on every single one of these, because it's always minus 1. So if I put a 1 in here for the first term, it's going to become a 0. And whatever's being multiplied by, it's also going to become a 0. So the first term should always be this number that's being added or subtracted that's not attached to the binomial. That's our starting point. And I'm making that kind of clear because I like to go over starting point and change when I'm doing linear functions, because that's a big deal when we start moving forward here. All right, so for the next one, let's set this up again. So if you notice, all of that is the same as the first one here. But now I'm going to go to the second term, or the second number in the sequence. So now I have 36, and I'm going to be a little lazy instead of repeating that. Well, I guess I can go ahead and write it. Minus 8 times 2 minus 1 is 1. So we have 36 minus 8 times 1 is 8. So we have 36 minus 8. So we simply just subtract those, and let's see, we get 28 for that one, if I bring it down by 8. So if we notice, and I don't know if we notice it yet, but hopefully we'll start to notice it, something is happening with this 8 each time. So let's pay attention to that as we move forward. Here, I'll type in 28 here, because that's my next number. Now I have I wrote 2. Losing my mind, that's why. A equals 36 minus 8 times something minus 1. So now we're going to move to the third term. Okay. So we have A to the third equals 36 minus 8 times 3 minus 1 is 2. So last time, the first time we had 0. The second time we got 1. The third time we have 2. So hopefully we can see that pattern happening. 0, 1, 2. And we're always multiplying that by 8 in this case. That's the rule for this sequence. So if we notice, we're always going to be bringing our next number down by a factor of 8. Or a multiple of 8. Sorry, not a factor of 8. A multiple of 8. So this is going to be 16 this time. 8 times 2 is 16. So now we're going to have A3 is equal to, or the third term of the sequence is equal to 20, because that's 8 less here. I can see that. So I start with 36, I subtract 8, and I get to 28. I subtract 8, and I get to 20. Right? So now I can see that's my pattern. I'm changing by 8 each time. That's my constant of variation that we went over in our last equation, or our last section. We were talking about direct variations and constant of variations, meaning what is it changing by each time? In this case, it's changing by 8 each time. Right? So I can even go through and I can guess. This is going to be 12. But let's go ahead and test it just to make sure. 36 minus 8 minus 1. So our fourth term would be 4 and 4. And we'd have A4 equals 36 minus 8 times 3, because 4 minus 1 is 3. A4, 36 minus 24. 8 times 3 is 24, and then 36 minus 24 is 12. So there you go. I knew what that next number was going to be just by paying attention to the pattern here. I could see I'm going down by 8 each time. Every time I do one more 8. Here's 1 8, here's 2 8s, here's 3 8s. So I can see that pattern happening. So this equation just helps us write down, it helps us work out any point in the equation or any point in the sequence. So I could ask you, what's the 100th term in the sequence? And we could very quickly find out without having to subtract 8 100 times. It's just a much faster way of doing that, is to have that sequence equation. All right, let's get rid of all that. Okay, so now they want us to, here's the first 3 terms of an arithmetic sequence. Remember, adding or subtracting. And we have 17, 25, and 33. Find the next 2 terms of the sequence. So we needed to figure out, okay, well, what is it changing by each time? I know my starting is 17, and my next number is 25, and my next number is 33. So I need to know, what is it changing by? What am I increasing by when I go from 17 to 25? Well, I'm adding 8 there. And then if I do this, I have 5 to 25 to 33, and that's going to be another 8. So there's my constant for right now, from what I can see, I'm going up by 8 each time. So I'm going to do that same thing. I'm just going to go 33, and I'm going to add 8 more. And let's see, we get 41, right? And then I'm going to add 8 more again for that because they want 2 terms. So I would get 49. So that's all they want us to do, is just pay attention to what is the pattern, what is it changing by. And again, we always want to pay attention to the 2 things. What are we starting with? And where are we going? How are we going? Are we adding? Are we subtracting? What are we adding? What are we subtracting? That's the change. So if you're in my class and you get to hear me, I say this all the time. What's the starting point and what's the change? Those are my 2 ways that I'm always talking about it. In this case, the starting point will be 17 and the change is 8, positive 8, because we're adding it. Alrighty. So we're going to do the same thing on number 3 here. We're just going to go through and look at what is our pattern. So I know what I'm starting on. There's my starting point. And now I have my first few pieces of the sequence here. I want to know, what am I changing by? So I'm going from -7 to -4. And if I look at a number line and I think about this, I have -7 and -4. And I'm going to put 0 somewhere over here. Well, if I'm moving this way, remember this is positive direction, this is negative direction. I must be adding something to move this direction. So in order to get from 7 to 4 is 3. So I must be adding 3. And then same thing, now I have -4 to -1. I'm moving in the positive direction again, so I'm adding 3 again. So there's my pattern. I know what I'm doing now. I'm going to add 3 each time. So I'm going to go to the next piece here, like this, and I'm going to add 3. So -1, and remember if you're looking at a number line again on this one, and I just erased that, we have -1, we have 0, and we want to get somewhere over here. We have 1 to get to 0, and then I need 2 more to add 3 total. So that would end up being 2, a positive 2. Now that we have positive 2 and I want to add 3, that's usually a little easier for students to, conceive and picture in their heads. 2, and I'm adding 3 more. Okay, well, you're going to land on 5, right? 2 plus 3 is 5. So just keep that in mind when you're looking at integers. And sometimes those number lines kind of help just so that you can think about the directionality of the numbers. Because a lot of the time that seems to help students understand, am I adding, am I subtracting? What are we doing to get from one number to the next? All right, so now in the next one, we're just going to determine, are they arithmetic or not? And if they are arithmetic, what that means is we're adding or subtracting the same number each time. So we should be able to see that pattern very quickly. So if we have 27, 20, 13, and 6, and then it goes ... meaning it goes on and on forever, or at least keeps going for now. So to go from 27 to 20, well, we're going down, right? And most students don't necessarily need a number line on this one, but you're welcome to draw one if you need one. Because usually we have 2 positives, we can see it's going down by 7. And then 20 to 13, I can also see it's going down by another 7. 13 to 6, oh, that's going down by another 7. And with this kind of stuff, we could even think of a story here to go with this to make sense of it. I had $27 at the beginning of the day, and every store I walk into, I spend $7. So I went to Albertsons, and then I went to Walmart, and then I decided to go to the candy store. So I went into 3 different stores, and each time I spent $7. So I have less and less money each time. Something along those lines. That's just kind of a silly story that I can come up with to explain what these numbers mean. All right, so I do see a common difference here, and it is -7. You want to make sure if it's negative, you put the negative in there. We want to indicate that it's going down by 7. It's not just a common difference of 7, but -7. All right, well, with these ones, I can see there's something a little off here because I'm going from 4 to 40 to 400 to 4,000. And if we think about this, this looks much more like multiplication than addition or subtraction, because I'd have to multiply by 10, multiply by 10, multiply by 10. There is a pattern there, but we're not looking for multiplication. We're looking for only addition or subtraction. That's what arithmetic means. All right, for that third one, we do have a smaller pattern here. So again, if we think of the number line, because since they're negatives, I like to look at the number line. 9, -6, somewhere over there, 0. So here are my numbers on a number line. And I can see I'm definitely moving toward the positives in this for each one, to go from 15 to 12, to go from 12 to 9, -9 to -9, -9 to -6. I'm definitely moving to the right. I'm adding something each time. So now I know I'm adding, and I can just think of, well, what's the difference between 15 and 12? To get from 15 to 12, that would be 3. So I'm adding 3 there. 12 to 9, same thing. The difference would be 3. 9 to 6, the difference is 3. So once I know if it's addition or subtraction, I understand that part. I can ignore the negatives just for a moment and say, okay, I know I'm going from -15 and I'm getting closer to 0, so I'm adding 3 in that case. So I'm just looking at 15 and 12, or 12 and 9, instead of worrying about those negative numbers. So I do have a common difference of +3. I don't have to put a plus sign here. No sign at all means positive. Alrighty. We're going to keep moving forward here. Okay. Find the 74th term of the following arithmetic sequence. So we have a little bit of work to do here. And I know I have kind of an exploration when I do this in class, because we want to keep going until we get to the 74th term, like this. And I'm putting ... and then 74th term. So this is the first, this is the second, this is the third, right? I'm just showing you fourth. Well, I want to go all the way to the 74th. I don't want to just find a pattern and have to go complete that pattern 74 times to get there. That would be, too much. I don't want to have to do that. So instead, I'm going to look at that idea we were looking at on number 1 when we were thinking about that equation. We always want to look at where are we starting and where are we going? How are we going? So starting and change. Those are the two pieces we want. So we're starting at 2, right? That's the beginning. That's my first term. And then my change here, that's going to be my common difference. That's what they call it in arithmetic sequence, but it's a change. So I'm changing. It looks like I'm going up. Each time from 2 to 10, I add 8. From 10 to 18, I add another 8. From 18 to 26, I add another 8. So there's my common difference. That's my change. I'm changing by 8 each time. So I'm starting at 2, and every time I move a term, I'm going another 8. So if we think about this, we know we're starting at 2, and we're going to have to add the change to this. That's how I keep moving forward. It's going to be 8, but it's not just 1 8. That's only if it was the, first term, or the second term, or the third term. I want one of each. So if I look at this and I go the first term, it wouldn't, if I go like this and I go 1, 2 plus 8, because this would be 2 plus 8, would give me 10. Oh, wait, but that's the second term. So there's actually another little piece we have to take into account here. Instead of just saying times the term number, it's always 1 minus 1. So we have, instead of just times 1, I have 2 plus 8 times n minus 1. And what n means is the term number. So this looks just like that equation we did on number 1. I'm going to flip back really quick, and I'll come back to this one. So this is what they gave us on the very first question we tried. We hadn't really explained a lot of it yet. I went through a bunch of it when we did it. But so now I have a starting point. My starting point in this one's 2. We also have 8 in this one, but it was minus 8. We're going to be adding 8 here. And then we can see that n minus 1. That's going to be a common theme here. We want to make sure that we acknowledge that we have to subtract 1 from it to be the correct numbering system. Otherwise, we'll be off by 1 term each time. So we have 2 plus 8, and then n, if I do first term like this, so if I'm looking for this first one, it would be 2 plus 1 times 1 is 0, and 8 times 0 is 0. So, oh, look at that, it got me my 2. And then with this one, if I think about it, if I go 2 minus 1 for the second term, minus 1, well, that would be 1, right? 2 minus 1 is 1. So that's why it gave me the second term. So this one does work. And we can even test it again and say 2 plus 8 times 3 minus 1. Well, 3 minus 1 is 2 times 8. 2 times 8 is 16. 16 plus 2 is 18. Look at that. It got me my third term. So it does, in fact, work. We are pretty happy with this guy. So now we can go ahead and use this same pattern, this equation here, on the whole sequence itself to find the 74th term. So I'm just going to come up here. I know I'm running out of room. I'm writing a little sloppy here. We have 2 plus 8 times the term number minus 1. So now I have 2 plus 8 times 73. And let's see. We have, I'm going to be, oops, maybe I'm not. There we go. I just wanted to grab the calculator instead of trying to guess this one. So we have 73 times 8 equals, and that's going to give me 584 plus 2. So now if I add 2 to this, I get 586. So that's definitely better than having to say plus 8, plus 8, plus 8, plus 8, plus 8, right? That's going to give us a lot of room for error. Because what if you don't add enough 8s to get there? That would be an issue. Or what if you add too many? It's very, very easy to lose track of it when you're doing that repeated addition. So this equation that we built makes it much easier. And if you understand this pattern, it's going to be the starting point plus the change times the term number minus 1. It always has to be term number minus 1. So that's always how we're going to set up these equations. So let's go ahead and type this guy in. So 586, check. All right. So find the 19th term of the arithmetic sequence whose common difference is 5, is d equals 5, and that's how we show the common difference in the equation when we're looking at it, and whose first term is a. So if I actually write this out as an equals a1 plus d times n minus 1. So this is actually what it looks like when we write this equation out. So this is the legitimate equation we just arrived at a few minutes ago. So if we know a1, this is the first term, that's how we note that. That means the first term of the sequence is 4. And the common difference is 5. Now we have an equation of this line, just like that. So the equation of this arithmetic sequence is 4 plus 5 times the term number minus 1. So we're always going to be multiplying by 5. That's what we're adding by each time. It depends on the term number on how many we add. So they're specifically asking us for the 19th term. So an and the 19 also goes here just to note it, if that's what you're looking for. Minus 1. So now we have a 19 equals 4 plus 5 times 19 minus 1 is 18. And we have plus, let's see, that would be 50 plus 40 more, so that would be 90. And then we just simply add 4 to it, and we get 94. Oh, and I gotta scooch this guy back over here so I can actually see it. 94. Check. Alrighty, so we are going to do one last problem here. And it's asking us for that equation that we want to write. So we've already been talking about this quite a bit. And as long as we know this format, we do want to understand what all these pieces mean. But that's what the kind of mini little exploration there was on, what was that, number 4? I think we were doing that, where we were kind of testing it out to see how we build this equation. So we always want to look at what is our starting point. Okay, I'm starting at 12. I can see that. That's the very first term here. So I know A1 is 12. Common difference, which is the D, that's what stands for here, is just what am I changing by? So to go from 12 to 15, I'm increasing by 3. 15 to 18, I'm increasing by 3 again. 18 to 21, I'm increasing by 3 again. So there's my common difference. N minus 1 is going to stay N minus 1 in this equation because we don't know what term number we're looking for yet. we're just writing equations, so we could ask for any term number at all. I could ask you for the third one. I could ask you for the 1,000th one. Using this equation, we can figure it out very, very quickly, whatever term number it is we're looking for. So that's why we leave it n, because it's open. It's our literally our variable that we can kind of mess with a little bit there. 3n minus 1. So we should be good to go on that guy. Yay! Oh, they're also showing me, so the alternate answer is they're showing me that I could have simplified here and gone 3 times n, 3 times negative 1, and I would have had 12 plus 3n minus 3. 12 and 3 are like terms, so I could have subtracted those, and I would have had this same equation. They mean the same thing. This is just leaving it in that sequence format, and this is simplifying it. So this actually looks more like what we're going to start to do in the future here when we start looking at specific forms for linear equations. So this looks very much so like a linear equation. In fact, it is one. All right, so that was section 5, and I will see you in section 6.